Our next presenter, our presentation is entitled Strip Tillage versus Conventional Tillage, Fresh Insight on a Long-Standing Controversy. And our presenter is Sujata Bogati.
Good morning, everyone. I hope everyone can hear me.
Yes, we can.
Thank you. I am Sujata Bogati, a master's student from the University of Georgia. So the topic of my presentation today is strip tillage versus conventional tillage of fresh insight on a long-standing controversy. So here is an outline of the presentation. I would like to start with introduction. As we know that Georgia is the largest producer of peanut, and Georgia it accounts for more than about half of the total U.S. peanut production, and it is a leguminous crop, and a leguminous crop requires adequate water requirement for its during its life cycle, and these are very sensitive to moisture stress condition. If adequate amount of water is not available, then it will reduce photosynthesis, yield, and quality of the peanuts. And in today's scenario, we have seen increasingly dry condition in Southeast. So we need to have certain water management strategies to cope with this situation. Normally in peanuts, there are two types of tillage system. One is conservation tillage system and another is conventional tillage system. So in our experiment, we are using strip tillage, one type of conservation tillage system, and another is conventional tillage system. Here I have highlighted benefits of both type of tillage system. Conservation tillage, as the name indicates, it conserves the soil, water, and energy. And since we use cover crop, it will also provide organic crop residues, and then it will reduce soil erosion, wind erosion, and also increases the soil fertility. Similarly, conventional tillage also have its own advantages. It provides a fine seed bed, and it will dries the soil for wetter climate, and also it reduces the incidence of weeds and pests. Also, it is considered to aerate the soil. However, there is controversy exists between superiority of conservation tillage over conventional tillage. Some of the literature says that conservation tillage is more preferable, and some other literature say conventional tillage is more preferable, and some of the paper also says that both the tillage, they don't have any differences. So the main reason behind our study is to see the differences between these, and we have seen increased pressure on water resources because of urbanization, population growth, and we have seen increased pressure on water resources. So we need to identify certain water conservation strategies, and we believe conservation tillage might be one. So water use efficiency, to our knowledge, it has not been studied in peanut between two tillage systems. And in this experiment, we are using Eddy-Covariance System. It has many advantages. Most important advantage is that it has a temporal and spatial advantage over other methods, because it directly measures carbon dioxide flux, evapotranspiration, and water use efficiency at the field scale, and continuously measures. Hypothesis of this experiment is that conservation tillage has greater water use efficiency and yield as compared to conventional tillage. And objectives of experiments are to quantify the influence of a strip tillage on water use optimization and yield of peanuts, and also to measure carbon dioxide flux, evapotranspiration, and water use efficiency between two tillage systems. Moving towards materials and methods, our experimental site was in Moultrie, Georgia. Here in the figure, we can see two plots of our experiment. One is strip tillage plot and another is conventional tillage. So Eddy-Covariance system was used in these plots, and peanut cultivar used was Georgia 06G, and seeding rate was 26 seeds per meter. And in this Eddy-Covariance system, there are mainly two main components. One is 3D sonic anemometer. Here in the figure, we can see one figure of sonic anemometer. This measures 3D wind direction. And this system is kept as at 1.5 meter height for peanuts. Also, we have another main component, open path gas analyzer. This measures the density of a gas. For our experiment, we are measuring carbon dioxide flux and water flux. So finally, this system is set up in the field, and then we will collect every week data, and then we get data in a frequency of 10 Hz. That means in 1 second, this system can measure 10 data points. So finally, when we collect the data, we will do an analysis by using software EddyPro, MATLAB, and like t-test is performed by using software JMP. And after doing analysis, we will get 30-minute average of carbon dioxide flux and evapotranspiration. And finally, we will calculate water use efficiency as a ratio of carbon dioxide flux and water flux. Here, carbon dioxide flux can be correlated to photosynthesis, and water flux is evapotranspiration. As water use efficiency has different definitions, we are using this type of definition. So we also measured leaf area index and did some soil sampling. And leaf area index was measured by using LAI 2000. And then while measuring leaf area index, we did for the both plots, like for strip tillage and conventional tillage, we identified 10 different locations in each plot, and then we measured LAI on a weekly basis throughout the season. So here are the preliminary results. Leaf area index. So here we can see leaf area index result. On the y-axis we have leaf area index, and on the x-axis we have day of year. And then this graph is divided into two different stages. One is from beginning bloom to full seed stage, and another is after beginning maturity stage. Here the green dots represent strip tillage, whereas red dot represent conventional tillage. So looking at the graph, we can see that leaf area index is greater for strip tillage as compared to conventional tillage for all these stages. Carbon dioxide flux. So carbon dioxide flux, here on the y-axis we have carbon dioxide flux for strip tillage, and x-axis we have carbon dioxide flux for conventional tillage. And on the top of that, we can see a same graph for LAI. I just wanted to correlate these two. So here, the blue dot represent beginning bloom to full seed stage, and orange represent after beginning maturity. So in this graph, we can see that all the points falls below 1-to-1 line, which is this line. And so we can say strip tillage had a greater carbon dioxide flux as compared to conventional tillage. And if we relate this with leaf area index was greater for strip tillage. That means there was more leaf canopies, or biomass of peanuts were greater as compared to conventional tillage. So so we can say that photosynthesis was greater in strip tillage as compared to conventional tillage. And we also performed a t-test and found that strip tillage had a greater carbon dioxide flux as compared to conventional tillage. Water flux or evapotranspiration. Here we can see conventional tillage water flux on the x-axis, and water flux of strip tillage on y-axis. So Here also we found that water flux was greater for strip tillage as compared to conventional tillage for all these stages, and leaf area index measurements also shows us the same result, because it has a more photosynthesis and more evapotranspiration going on in strip tillage field as compared to conventional tillage. So t-test also showed strip tillage had greater water flux as compared to conventional tillage. Moving towards water use efficiency and yield. So here also we have a strip tillage water use efficiency on y-axis, and x-axis we have water use efficiency for conventional tillage. We made a ratio of carbon dioxide flux and water flux, and finally calculated water use efficiency, and found that strip tillage had greater water use efficiency as compared to conventional tillage. So we also measured a yield, and for yield also we got the same result. Finally, to summarize this experiment, water use efficiency for all the stages was greater for strip tillage as compared to conventional tillage. And yield was also found greater for strip tillage. And we think it's because LAI also showed the same type of result. That means there was more biomass in the strip tillage, more photosynthesis going on. So we had a greater water use efficiency for strip tillage as compared to conventional tillage. So our future plan is continuation of the same experiment and measuring leaf area index on a weekly basis and soil sampling. So this year we are planning to do, we are already starting our soil sampling at the beginning of the season and at the end of season, so that we can compare it, and then also to take a biomass sampling. And finally, I would like to acknowledge my advisory committee, my major advisor, Dr. Monique Leclerc, my co-advisor, Dr. Robert Scott Toffs, and then all my LEAP lab members, my lab members, a National Peanut Board for providing funding support, and Sunbelt Agriculture Expo, Cordy Mitchell. Thank you, and I will take any questions.
Thank you for that presentation. We have questions already. The first question comes from Dr. Perry Tillman, and his question is, what cover crop did you use in your research, and would one system be preferred over the other in non-irrigated fields? So again, what cover crop was used, and would one of your systems be better over the other in a non-irrigated field?
So the question was, which cover crop was used? So cover crop was cotton for this experiment, and so in this is a unique experimental setup where we use one type of Eddy-Covariance system, and it can measure fluxes over a whole field. So for our experiment, we used different Eddy-Covariance system for different plots. So, yeah.
Okay. And as far as whether it's irrigated or non-irrigated, would that make a difference in what a grower chose to do based upon your research, as far as one system or another?
So for this experiment, both the fields were irrigated. We considered the same, keeping same type of treatment, like irrigated for both of the plots.
Okay, thank you. Our next question comes and says, can you comment, or did you note the difference in severity of tomato spotted wilt virus, and would it have contributed to peanut biomass and or yield differences based upon your tillage practices? So did you see any difference in tomato spotted wilt virus between your treatments, and would it have contributed to your difference in biomass and or yield?
So the question was about tomato spotted wilt virus. So since our experiment, it does not count for disease, we are just concerned only with measuring the fluxes, water fluxes. However, it could be possible that like tomato spotted wilting virus will be less in strip-tillage, as we have seen in many papers. But we are not actually doing such type of experiment to exactly know. So I'm not sure about that.
Okay, and we have time for one final question. This comes from Dr. Michael Mulvaney. His question is, why would soil water flux be greater under strip till compared to conventional? Why would soil water flux be greater in strip till versus conventional?
So the question was why the water flux would be greater in strip tillage than conventional tillage. So as our leaf area index, I will show from the graph. So we have seen that leaf area index for strip tillage was greater. That means it has more biomass or more leaf canopies. So there will be more transpiration and more evapotranspiration from strip tillage field. So which will result water flux to be greater as compared to conventional tillage.
Okay. All right, that's the time we have for questions. Thank you very much. I will say if there's one last question, this is not for you, but I would like to see Dr. Anko ask Dr. Tubbs this. The question reads, based on your results, what is wrong with Dr. Tubbs' data summary and UGA Peanut Quick Reference Guide? So Dan and Scott, I'll look forward to you all asking and answering that question, and I'll come see what you have to say about it. So that concludes our time for this questions, and thank you very much to our speaker.
Thank you.